So this lesson will be about diodes. Alright. Oh shit. Okay, diodes, yeah. And BJTs. This is BJTs will be filmed in a separate video. For now, diodes, yes. So you probably know what a diode is already, but let me refresh your memory. A diode, right, is an electrical component. Let me just draw it out. Okay, and a diode simply, right, allows current to flow very, very easily in one direction, but resists the current in the other direction. And to identify this direction, you can just look at the symbol. You can see that this looks like an arrow, right? And it's pointing in this direction. So it allows current to flow easily to the right, and it resists the current flowing to the left because the current is blocked by this bar. That's just an easy way to remember it. Okay, so that's what a diode does, but we can actually go a bit more in depth on how it works. Okay, so in the world of semiconductors, there are two types of semiconductors that you should know lah. One is the P type semiconductor and the other is the N type semiconductor. And then I won't go into why it works, but when you combine them together, right, like this, and you put a wire like that, this is the same as this. So yeah, maybe I'll do a video on these in the future, but that's out of syllabus, I think. So this diode is made up of one P-type semiconductor and one N-type semiconductor. When you put them together, you form the diode, yeah. And this is the anode, this is the cathode, and this is the junction. Crap, am I right? Yeah, that's the anode, okay. Cathode. And this is called the PN junction. So yeah, okay. Let me put this to the side. Okay, so next thing I'm going to talk about is how to describe the behavior of a diode using graphs instead of just talking about it. So I'm actually going to draw two different types of graphs representing two different types of diodes. Okay, the first graph will be talking about an ideal diode, and the next one will be talking about a practical diode. Practical diode, and I'll talk about what these mean. Okay, so diode model net. Actually, okay, yeah, it's a model of a diode. Yeah, okay. So what is an ideal diode? Okay, I'm just going to draw the graph first, and then I'll explain. Okay, so this is current, this is voltage, and in this graph we are observing the characteristics of the diode. So for voltage, right, you can imagine we are taking a multimeter, right, and we are probing it like this, V, and then this will get us our voltage. So okay, and then the current would just be like an ammeter somewhere. Yeah, sure. Okay, so we're gonna now describe the allow current to flow in one direction, resist the current in the other direction using this graph. Okay, so let's say voltage is negative. Okay, here in this region the voltage is negative, and that means it's flowing this way. So recall it'll be blocked by the bar, so it's resisting the current, and we can describe this as the current when voltage is negative being zero, like that. Okay, so as long as the voltage is negative, in the model of an ideal diode, the current is 0. Okay. Next is when the voltage is positive. So now the current is flowing in this direction. And that would mean that we want to allow the current to flow through. So we can just say that it's as high as it can go. Yeah, like that. And that is the graph of an ideal diode. We can describe a few more things about this graph. We can say this entire region is, we can name this region as something called, we can say that the diode is forward biased. Okay. And in this region, we say that the diode is reverse biased, reverse biased, reverse biased, reverse biased, reversed biased, uh, reverse biased. Okay. And that's the graph of an ideal diode. Alright, let's draw a practical diode now. So, what I mean by practical diode is the behavior of a diode you actually use in real life, in your coursework or in a computer or whatever, will behave like this practical diode. Okay, you will never see this in real life ever. No diode will look like this. Maybe in very specific circumstances, but you will never see this. Okay, so let's start like how we did while describing the an ideal diode. Let's start when the voltage is negative. So in a practical diode, we can actually say the same. When the voltage is negative, right, the current will actually be 0, be very low. To a certain extent, if the voltage is negative enough, is very low, low enough, the voltage will actually break down, allowing a massive current to flow in the opposite direction. Okay, so to put in layman terms, if the voltage is low enough or is high enough in the opposite direction, denoted by this massive arrow, then the arrow will break through the bar and just flow through in the opposite direction, like that. So that's what's happening. And then we can actually say the same in positive voltage. The current will be high, but it's not high immediately. What I mean is, in the ideal diode, the moment the voltage is positive, or the moment there's a small voltage going in the right direction, then the current is immediately high. Okay, but in the case of a practical diode, it will not immediately become high. It'll look something like this. So after a certain voltage, then it will become high. So I've been just naming things around without like actually saying the names of them. So I'll tell you again. I'll tell you what the names are. Just like describing forward bias, reverse bias, we can actually name some of the regions here. For instance, this area here, this area is called, okay, I'm running out of space. Black. Okay, this part here is called the knee voltage. Knee voltage. Cool. And then this is where the diode is on, and this entire part is the diode being forward biased, but just know that I'm not going to illustrate it out. Okay, and this area here, colors, this area here is known as the breakdown region, breakdown voltage. And then when the diode, right, allows the current to flow in the opposite direction, this area is known as the breakdown region. Okay. And that's pretty much practical diode and ideal diode. There's of course additional information you should know. For most diodes, right, the knee voltage is 0.7 volts. So for silicon diodes, the knee voltage is usually 0.7 volts, meaning the voltage the voltage going in this direction, right, needs to be higher than 0.7 volts for it to be on, for it to allow the current to flow through. And there's another thing that you might need to know. For diodes made out of germanium, the knee voltage is 0.3 volts. And that's just a very brief overview of diodes. In a future video, I'll be talking about how you can use diodes to turn alternating current into direct current. So okay, yeah, that's that for this video.